So this lesson is on adding and subtracting radicals, but before we move on to that, I just want to review the three critical radical rules that you've learned so far. That is to simplify all perfect squares in all cases with radicals. You can't have any fractions under the radical. And then so if you have to break up a fraction, you need to also remove the radical from the denominator. So all three of those rules apply at all times, something to keep in mind as you're simplifying any radical expressions. Okay, let's look at adding and subtracting radicals. Now, with multiplying radicals, you can multiply any two radicals together and get a product. The next video I'm going to do is going to focus on some more complex multiplication examples with radicals. When I'm adding, I need a common radical base, if you will, in order to add them. So if I have this expression 3 root 2 plus 3 root 5, I need the radicals to be the same in order to add these together. So since these are square roots that are already simplified, I can't add these. So I just want to note that something like this would already be considered simplified. So let's look at the second example. I have 9 root 7 minus 4 root 7. These have the common radical 7. So we're going to treat it, I want you to think of it, for starters, almost as if this is 9x minus 4x. I don't want you to actually change the problem into variables, but from what you learned earlier in this course, if we had 9x minus 4x, we know that would equal 5x. So in this case, if I take away 4 root 7 from 9 root 7, this is going to leave me with 5 root 7. That's how we add and subtract radicals. So let's do two examples where right off the bat we don't have common radicals. I have 2 root 7 plus root 28. Now we always have to simplify the radicals. So I know 2 root 7 looks good, but let's think about root 28. Root 28 has a perfect square of 4 and 7. So I'm going to change this into another 2 root 7. Let's bring this 2 root 7 down. If I have 2 root 7 plus 2 root 7, my answer is 4 root 7. Give this one a try on your own. Hit pause. And I'll go ahead and do it myself. We have, now one thing about these problems is usually you have a bigger radical that needs to be simplified here. You have a smaller radical that's already simplified right here. Usually this number is a good hint to you to tell you that, okay, if they want me to add or subtract these terms, it's pretty likely that this is going to be simplifiable down to something that gives me a root 5 in order that I can do something with this. So we know that the perfect square factors for 125 are 25 and 5. Remember to show your work on these problems so you don't get ahead of yourself. So that becomes 5 root 5. I'm just going to bring down the term that was already simplified. And if I take 2 away from 5, that gives me 3 root 5. Okay, 3 root 5. Let's do one example with 3 terms. You could have 3, 4, 5 terms here with addition and subtraction problems. So we have to consider each of the terms if they're simplified and then see which ones we can potentially combine. 3 root 2, that's simplified already. Root 98, perfect square factors. This one's going to be 49 and 2. So this term becomes 7 root 2. Those look like terms I can combine. Let's see if there's going to be a third term which I could combine all together here. Now we have a coefficient already out in front here, so when I simplify, remember that's going to get multiplied by anything that gets pulled out of this radical 20. So it's going to be negative 4 perfect square factor perfect square factor of root 4 root 5. Let's go minus 4 times 2 root 5. And then ultimately this term is minus 8 root 5. So I'm going to write these terms one more time so they're all on the same level with each other. So you probably noticed that that third term does not have a common radical in common with the first two terms. That's okay. We can combine these two. 3 and 7 positive gives me 10 root 2 minus 8 root 5. And that expression's simplified. That's all I can do with this one. So it's perfectly fine to leave your answer just like this.